All right, so today we're going to be covering trig functions. It's very similar to what we were doing before. All we're doing is setting up the ratios for today. So it says in a right triangle, there are actually 6 possible trigonometric ratios or functions. So the ones that we did learn already are the sine function, which is your opposite over hypotenuse. Your cosine function is adjacent over hypotenuse. And your tangent is your opposite over adjacent. All right, and so we learned this, I believe everybody teaches it a different way, but we learned it as SOHCAHTOA. There are acronyms for this, so some old hippie caught another hippie tripping on acid. Whatever you want to remember it as, you use whatever you learned. But then sine has a reciprocal function. So its reciprocal function is cosecant. And so reciprocal, when we had fractions, for example, 1/2, the reciprocal means 2/1, okay, when you flip the fraction around. So our reciprocal trig function would be cosecant. So instead of having the O over the H, you're going to do your hypotenuse over your opposite. So all you do is just flip over the fraction, and that is cosecant. And you have cosine. So cosine, the reciprocal function of cosine is secant. Okay, so instead of being your adjacent over your hypotenuse, it is going to be your hypotenuse over your adjacent. Okay, and then the last is tangent. So your tangent, its reciprocal function is called cotangent. And so cotangent, instead of being opposite over adjacent, it's going to be the adjacent over the opposite. So you flip over the fraction. Okay, pretty much is what it is. If we look here at the examples, it says, notice that the 3 new ratios are reciprocals of the ratios to the left. Express the exact 6 trig functions of angle theta of each triangle. Leave your answer in simplest radical form when applicable. All right, so on here we have, this is 6. Now 6 is opposite our angle theta. Here's our angle theta, so that means 6 is opposite. So I'm going to put right here, opposite, OPP, for opposite. And then for 8, this is adjacent to this angle. So I'm going to put here ADJ. And then last, the side across your 90-degree angle is your hypotenuse. It's your longest side. So HYP for hypotenuse. And so, unfortunately, we do not know what the hypotenuse is, so we do have to solve for it, and we're going to do that using a squared plus b squared equals c squared. So I'm going to do 6 squared plus 8 squared, which gives me 100, and that equals c squared. I take the square root, and that gives me 10. So 10 equals my hypotenuse c. Okay, so now I'm ready to find my trig function. So if I look here, first is going to be sine, and I'm going to write it off here to the side. Sine is opposite over your hypotenuse. And so here in this case, our opposite is the 6. So I'm going to write 6 over 10. Now this fraction we can reduce. It is going to give us, if we reduce it, we can divide both by 2, so it'll end up being 3 over 5. And so your cosecant is the reciprocal function for sine. So instead of being 3 over 5, it becomes 5 over 3. And that's it. So let's try the next one, your cosine. So your cosine function is going to be your adjacent side over your hypotenuse. So I'm going to put here a over h. And so my adjacent, we know, or we already said, was 8, and my hypotenuse is 10. So it's going to be 8 over 10. But we can reduce 8 over 10. If we reduce it, it becomes 4 over 5. Sorry, I didn't leave myself enough space. And then your reciprocal function, which is secant, is going to be 5 over 4. All right. And then last is tangent. So our tangent function is when we take our opposite and divide it by our adjacent. Okay, so here our opposite is 6 and our adjacent is 8. And so 6 over 8 is going to reduce to 3 over 4. And then cotangent is our reciprocal function. So instead of being 3 over 4, we flip it over, and it is 4 over 3. And that's it. Those are our values for our 6 trig functions. Okay, let's look at the next one. So on this one, we have, they give us theta. This is my opposite. This is my adjacent. I don't know what it is. And then our hypotenuse is the longest side, the side across the 90-degree angle. Okay, so we're going to have to find the adjacent side using a squared plus b squared equals c squared. So 4 squared is our hypotenuse. So we know that 3 squared gives us 9 plus b squared equals 4 squared is 16. We subtract the 9. And we get b squared equals 16 minus 9 gives us 7. And then we take the square root. And so we're going to leave this in radical form. So we're going to leave it as b equals the square root of 7. Okay, so that's our adjacent side right here, is the square root of 7. Okay, so now we're ready to set up our trig ratios. So it's going to be, for sine first, it's going to be our opposite over our hypotenuse. So my opposite side we had already said was 3. So it's going to be 3 over 4. And 3 over 4 we can't simplify, so we're going to leave it like that. And then for our reciprocal function, which is cosecant, it is going to be 4 over 3. All right, next is going to be our cosine. So our cosine is going to be adjacent over hypotenuse. And so our adjacent side we said was the square root of 7. So here it's going to be the square root of 7 over our hypotenuse, which is 4. And so for our reciprocal function, we are going to have to flip that around, and it's going to become 4 over the square root of 7. Okay, now there is a rule that we cannot have a square root on the denominator. So we are going to do something called rationalize. So to rationalize it is to get rid of the square root on the bottom. So the only way to get rid of the square root of 7 on the bottom is to multiply it by the square root of 7. But we can't just multiply on the bottom. We also have to do it on the top just to keep it even or to keep it equal. And so on the top, we're left with 4 times the square root of 7. And then on the bottom, if you get the square root of 7 times the square root of 7, it is going to give you 7. So that would be our answer simplified. And the last one, our tangent is going to be opposite over our adjacent. Okay, so our opposite is going to be 3. Our adjacent side is the square root of 7. And then from there, we have to simplify it. Okay, but first let me go ahead and flip it over real quick for cotangent. So the reciprocal is cotangent, which would be the square root of 7 over 3. Okay. This one we don't have to rationalize. That would just be our answer because the square root's on the top. We don't have anything to worry about. I didn't box these ones. And then for the 3 divided by the square root of 7, we're going to have to rationalize that. So we're going to have to multiply the top and the bottom by the square root of 7. And that ends up giving us 3 and the square root of 7 on the top. And then the square root of 7 times the square root of 7 gives you only 7. Okay. And then that is the simplified version. All right. Now for the next one. So the next one tells you, given cosine of theta is equal to 12 over 13, find the exact value of the other 5 trig functions. Okay, this one doesn't give us a picture, so we're going to have to draw the picture ourselves. So I'm going to draw a triangle. I'm going to put my right angle, and then I'm going to label my angle theta. So say this is my angle theta. That makes this side the opposite, this side the adjacent, and this side the hypotenuse. All right, and then from there, they tell us that cosine is 12 over 13. So I'm going to fill it in here. They give us that it is 12 over 13, which means that our secant is going to be 13 over 12. Okay, so we have to flip it around. Now we know that our cosine is adjacent over hypotenuse, which means that the adjacent side is equal to 12. So for here, this side is equal to 12. I'm going to label it in my picture. That also means that our hypotenuse is going to be 13. So HYP is 13. So I'm going to label it on my triangle. Then from there, I can go ahead and use a squared plus b squared equals c squared to find my missing side. So a squared plus 12 squared equals 13 squared. And so a squared plus 144, because 12 squared gives you 144, equals 169. We subtract the 144, and we get a squared equals 25. We take the square root and we find that our missing side is going to be 5, because the square root of 25 is 5. Our opposite side is 5. Okay, now we can finish the rest of our trig ratio. So our sine is opposite over hypotenuse, and now we know our opposite is 5. So it's going to be 5 over, and our hypotenuse is 13, which makes our reciprocal function 13 over 5. We flip the fraction. And then last is tangent. Tangent is opposite over adjacent. We know that our opposite is 5, and our adjacent is 12, so it's 5 over 12. And then cotangent becomes 12 over 5. Now, none of these we can simplify. They are already in simplest form. So these would be our answers. And that's it. All right, the last example. So on here it says, given sine of theta is equal to 2 over 3, find the exact value of the other 6 trig functions. Okay, so sine is 2 over 3. I'm going to do the same thing. I'm going to make my triangle. So here's my triangle right here. Here's my right angle. This is theta, my angle theta. This is my opposite side. This is my hypotenuse. And this is my adjacent side. Okay. And then they tell us sine of theta is 2 over 3. So sine is 2 over 3. And we know that sine is opposite over hypotenuse. So that means that the opposite is 2 and the hypotenuse is 3. Okay. If sine is 2 over 3, then we can find its reciprocal function cosecant. It becomes 3 over 2. All we have to do is flip the fraction over. And so in order for us to find cosine and tangent, we're going to have to find the adjacent side using Pythagorean theorem. So we're going to use a squared plus b squared equals c squared. And so 2 squared gives us 4 plus b squared equals 3 squared is 9. We subtract the 4 and we get b squared equals 5. And we take the square root and we're going to leave it in radical form. So it's going to be b equals the square root of 5. So then that means that our adjacent side is the square root of 5. So we're ready to start our trig function. So cosine is going to be adjacent over hypotenuse, which we know the adjacent side now is the square root of 5 over the hypotenuse is 3. And then for secant, we're going to go ahead and flip the fraction, becomes 3 over the square root of 5. And so on here, we're not allowed to have a square root on the bottom, so we have to rationalize by multiplying the top and the bottom by the square root of 5. And so it's going to give us 3 in the square root of 5 over the square root of 5 times the square root of 5 just gives us 5. All right, for the next one, tangent. So tangent's going to be opposite over adjacent. So we know our opposite side is 2, and our adjacent side is the square root of 5. And so the same thing happens like on the last problem. We end up with the square root on the bottom, and we're not supposed to. So we need to rationalize the function. So in order for us to get rid of the square root on the bottom, we have to multiply the top and the bottom by the square root of 5. which ends up giving us 2 and the square root of 5 on the top. And then on the bottom, the square root of 5 times the square root of 5 is just 5. And that would be your solution for tangent of theta. And so for cotangent, if we do opposite over adjacent, we flip it around. Your adjacent is the square root of 5, and your opposite is 2. And this one we don't have to rationalize because the square root is on top, and we're done there. That's it. If you guys have any questions, go ahead and leave it in the comments, and I'll go ahead and answer them as soon as possible. Bye.